while I leave up this badge, I'm going to bring on Rami, who is the DevRel lead for the Metis Layer 2. Where'd you go, bud? There you are. Hi, Rami. How you doing?
How are you, Kat? I'm doing great.
Absolutely fantastic. Alrighty, I'm going to leave up this badge for just
take your time. Let's also wait for Ivan a little bit.
Okay, sure. Awesome. Should blah, blah, blah. What am I thinking? We'll put up your slide. So we have Ivan joining us in just a minute. We're just waiting to bring him up into the studio, which takes a little bit of time for StreamYard to do. But
all right.
We'll just...
So I will just go ahead then.
Okay.
Ivan can join later because he can present about Parsiq a bit later. So hello everyone. Good morning, good afternoon, good whatever. Thank you everyone for joining us. Really appreciate also the opportunity for presenting here. Today we're going to be building a voting system and deploying it to Metis L2 network. And our friends from Parsiq are going to help us to index the contract that we're going to deploy. And we're going to see how easy it is to index the contract and do all sorts of things with it. So let's get started. Can you move on to the next slide? So about me, I'm an experienced hacker in Web3. I like to call myself a hacker. I'm an engineer. I have a background in cybersecurity, starting from 2019. Love to participate in hackathons, CTFs, and so on. Actually, I learned about the Ethereum blockchain from a CTF back in 2020, and that's how I ended up here. Currently, I'm leading the Metis DevRel team, and I have worked on various projects and integrations, mainly focusing on smart contract wallets and ownership, DeFi, and Web3 analytics, among others. We have also joining us is Ivan. He's a wonderful sales engineer in Parsiq and co-host of a blockchain podcast, Basic Block, with a background in Web3 and in Web2 and Web3 security. In Parsiq, Ivan builds a bridge between the users and the dev team, learning about the client's needs, making sure the product covers them, as well as sharing what it can be used for and how. All right. So what's on the agenda? What are we going to discuss today? First, we're going to discuss Ethereum blockchain. What is it? How does it work? I believe a lot of people before me, especially Philippe, talked about Ethereum and Ethereum scaling. So we're not going to delve into that very deeply. Save some more time for our next presenters. We also gonna learn about Solidity, the programming language for Ethereum blockchain. Learn about layer 2 solutions and what is Metis layer 2. We're going to be also deploying the contract. We're going to go see how easy and simple it is to write a contract and deploy it without even using a no-code tool. You can just deploy it from your own workspace, just like a real hacker. That's what we're going to do. And then we're going to interact with the contracts, learn about the events and the entities of the contracts. And then Parsiq, Mr. Ivan is going to help us to use the 𝘝𝘚𝘁𝘶 API and fetch the contract data in real time. All right, so Ethereum, what is it? As we know the blockchain, we know that it's the set of blocks and each block contains the transactions. This is like any blockchain, that's the definition of it. It's the set of blocks and the set of these transactions inside the blocks. Now, Ethereum introduces smart contracts, which are code that lives on the blockchain. All right, that's how we can think of it. code that lives on the blockchain that can be executed when called. And so how these contracts are executed using the EVM, which is the Ethereum virtual machine. So the Ethereum virtual machine just runs this compiled bytecode for the contract. So every time you call a function in a contract, this function call, so for example, you say when you're transferring a USDT token, you're calling transfer from to, all right? It's like very straightforward. You see it in Solidity, but it is actually translated into some bytecode, in some hex encoded bytecode that the EVM understands and knows what to do with it. So when I call transfer, it becomes like 0x96 something. And then the EVM takes this, all right, so this transfer event is going to this contract. So, all right, I'm reading this contract. Okay, so the function signature is 0x96 something something. So this is the function signature for transferring. All right, I'm gonna read this contract. I'm gonna read this transfer function. I'm just gonna take these encoded also parameters for the function, and I'm gonna execute them. That's how the EVM works. So that's how it just runs the smart contracts in a simple way. I might have maybe I said it wrong, but like that's about it. That's how it works. Now the challenges of Ethereum, just like Philippe mentioned, it's like almost everybody mentioned before me. It's like an expensive chain. It's a chain of chains. It's not a chain for users because it's quite slow. Like it has a TPS of about 30 transactions per block or per second, like 30 TPS, yeah. And the challenges are like scalability, all right, and it is expensive also. So the EVM, the Ethereum virtual machine, it's a machine, so it consumes gas, we can say. That I'm pretty sure you all heard about gas that you use for sending transaction. So if you worked around with MetaMask or any other self-custodial wallet, I'm pretty sure you know about gas. When you cannot send the transaction when you have 0 Ethereum on the Ethereum blockchain, and Ethereum is expensive, transactions are expensive. Sometimes like deploying a contract on Ethereum can cost you up to like I don't know, I think I once deployed a contract on Ethereum. It cost me like $500, which is like crazy for if we compare to other chains, for example, like Metis chain. Now we will see like it costs nothing to deploy the contract here. So yeah, that's pretty much it. Scaling, that's our problem here, and that's what we aim to solve with layer 2 solutions. We will explore this a bit later. So what is Solidity? This is like the Solidity compiler help. I like to be quirky, hacky here. Solidity is the most used programming language on the Ethereum blockchain. It's the most famous. There is also other languages like Viper, some people use Rust for writing smart contracts, but I think the most used language is Solidity, as it's very simple, it's very straightforward, it's pretty much like English, as you will see a bit later. So Solidity is not, when we talk about the EVM doesn't understand Solidity. Solidity is just like how any programming language is not exactly a machine language, it's a human language, all right? So Solidity is a human language. Now, Solidity compiler takes this human language, which is Solidity, which a language we understand, all right, and compiles it into bytecode that the EVM understands. The Ethereum virtual machine would understand the bytecode. How it is used in smart contract development, very straightforward. We will see a bit later. key features, we have something like inheritance or like polymorphism, a lot of very cool features that you will learn about. And where can you learn about Ethereum or Solidity language? I think the best place, the best resource, and where I've personally learned about it is the reference and the documentation for Solidity language. In my opinion, that can be the best place to just go deep dive into any data type, any call, any internal call, anything. You can just go through the documentation, and I think it will be the best option. Optionally, you can. There's a lot of tutorials on YouTube. There's I think there was like a 24-hour bootcamp. A lot of my friends actually took this bootcamp by Free Code Academy, something like this. If you need it, just DM us on Twitter and we can send it to you. All right, next. Layer 2 solutions. Everybody talked about this. We're aiming to close the gap so we have the blockchain trilemma, which is security, scalability, and decentralization sitting at a triangle. So like if you focus on scalability and decentralization, you might be sacrificing a little bit security. If you focus on security and decentralization, just like Ethereum, so Ethereum is a highly secure, highly decentralized network. It sacrifices a lot in scalability. So what we're trying to do is to close this gap between these three items as much as possible, to try to be like right in the middle of this blockchain trilemma. And like we're trying to achieve, so we're already very scalable. We already have the cheapest transactions. And we're already very secure. Also, we're trying to achieve now more decentralizations. Like we have a lot of updates, exciting updates to come about decentralization. So stay tuned to our Twitter. And so the layer 2, if I need to explain it to you, is a way that it's like another chain that runs under Ethereum. All right, so Ethereum is like the giga chain, we can say, and there would be like a contract on Ethereum, all right, that records these transactions from the other chain. All right, for example, like a very basic layer 2 solution would be to just run another chain, all right, and take these transactions, like take, for example, 100 transactions, compress them, and put them on Ethereum. This way, you don't pay gas for these 100 transactions. You pay gas for one transaction. You pay slightly more, but for just one transaction, and like that's how you can scale Ethereum. You take some of the transactions off of Ethereum chain, and you execute them like off the chain, all right, on another chain, for example, on our chain, and then you roll them like a piece of paper, and then put them on Ethereum in a compressed way, in a way that doesn't cost so much gas. That's how we make it very very cheap for our users to send transactions. And yeah, now here we are. If you haven't heard of a decentralized application, it's an application that interacts with a smart contract. Basically, it's a Web3 application. So what is a Web3 application from a technical point of view, from like a developer point of view? So the simplest application consists of like two items. One is the front end, all right? The second item is the smart contract. So the front end, or the client side, this is the code that runs on your side, on my machine, on my computer. It doesn't run on a server, all right? So like essentially you can download this client code, all right? Disconnect from the internet. Do not, like, you can also, you don't even need to connect to some network or something. You just need to have access to the Ethereum network. All right, that's how you can run a decentralized application. That's how it is actually decentralized. Like there's no server that can mess up with your data. There is no server that's storing your data. Yeah, it consists of the front end, all right, and the calls to the smart contract. So the front end calls to the smart contract. The smart contract is on the blockchain. The front end is on your computer, you can say. So here we do not see a backend also. Like, yeah, sometimes the front end is hosted on a web server. Some very quirky people like to host it on, like, for example, IPFS, to have more decentralization, because web server, like, for example, the content of a web server can be changed by the owner of this web server, but that's how people can, like, try to make it more decentralized, to host it somewhere where it cannot be changed, or like the URL is stays the same, then the content stays the same, doesn't change. So the backend here, there's no backend. The smart contracts kind of play the role of backend here in this DApp. Sometimes people can put also like an extra layer of a backend to store some data. If your app is heavy on data usage, you can store some of it on the backend. But the most decentralized app is just a front end and a smart contract. And now for the exciting part, we're gonna go ahead and show you our repository template. I have made a repository that you can use for like starting up your very simple smart contract if you want to deploy to Ethereum blockchain. So let me share my screen real quick. Share screen. All right. Kat, can you bring my screen up, please? All right, here we go. So let me just delete this real quick. This is not used. Okay. All right. Okay. So this is our repository. You can find it at the link is actually in the presentation. I will show you the link in the end, but I will just walk you through the repository real quick. I will show you, like, what do we have here. It is a voting system. All right. So this is the contract. This is the Solidity contract. As you can see, it has the file name, the file type Sol, which is for Solidity. It's a voting system. As you can see here, we have an owner. We have we can actually replace the owner with ownable. One sec. Or no, we don't need to. So we have an owner for the voting system, which is like, it can be a governor. This is a very simple contract. Actually, do not use this in production. This is just for a tutorial purpose. So this has not been tested or anything. And this also, like, doesn't make much sense, this contract. It's just for the sake of this tutorial. We have the owner, which can add candidates. All right. We have the list of candidates, or the mapping of candidates. So there would be the candidate ID that maps to a candidate struct. We have the struct type here. So, like, we have some basic data types in Solidity, which are very basic. Like, there's the address, there's the uint, there's the int, there's the boolean. But for example, if you need to, yeah, there's the string also, of course. If you need to do a more complex data type, you can use structs, just like we did here, which takes this data, all right, and puts them all together in one object. It's just like objects in, like, you can compare it to structs or classes in other standard programming languages, like C or C++ or whatever. Yeah, C doesn't have class, I know. All right, so it just takes this data together in a struct and encodes them to have one data type. So yeah, this mapping maps from the candidate ID to the candidate object. And this mapping maps the votes to the uint. Here, like each address, how much they voted. So if I search for the votes of my address, I can see how much tokens I devoted for this candidate, or how much tokens I voted in general. We have the candidates count. We have the voting token, which we'll see a bit later. So here we have events. On the blockchain, we have this thing called events. All right. So how do these wallets, for example, MetaMask, track your transfer events and everything? They just they can track these events, all right, to keep track of your balance, all right. So, for example, the ERC contract, which is the contract for almost all the tokens. Let me see. Actually, we're not gonna see it right now, but like there's a transfer event which specifies your address and the from address, which is the address that is sent from, all right, the to address and the amount. And that's how, like, MetaMask, for example, tracks your balance. So here we have these events, all right. You can choose to emit them anytime you want. Indexed means it will be, you can, indexed, actually, you can use it for like filtering. If you do not, if for example, this new candidate event, I do not put an index for the name, it means I cannot, it will be more difficult for me to filter these events by the name. But index means you can filter with them. And you can do a lot of other cool stuff with index. So if it's an important parameter, you can just put index before it and voila. All right. So the constructor is the entry point when you deploy contract. This is the function that gets deployed, that gets called, sorry, when you deploy the contract. So once I deploy the contract, the constructor will be executed, and it makes the owner as the message sender, which is like the sender of the deployer of the contract would be the owner here. And the voting token is here in the parameters, all right? Now the modifiers, they are like a precondition or something that is executed before the function call. So here, for example, add candidate has the modifier only owner. So only the owner can call this function, all right? Here, you can write whatever code you want. And then this little thing right here, it means, all right, call the function now. So this will be executed before the function call. It will just make sure that the message sender is the owner. That's why it's called on the owner. Makes sense, right? Yeah. Here, add candidate. You can give it a name, and then it emits a new candidate. You can look at the logic a bit later once you explore the repository. And so yeah, it will emit a new candidate event, which we will see with Parsiq. And then we have the vote function, which is public. So anybody can call this function and vote for the candidate that they want. So they can use the voting token, all right, to, if I have some voting token, I can use this voting token to vote for someone, all right? So we have the candidate ID. Yeah, just like requirement statement means, all right, check for this condition. If it doesn't apply, if it's not true, then you just emit this error. That's it. And then, yeah, in the end, we emit a new vote event, which we'll also see with Parsiq. Now here, you can write deployments, a deploy script for the contract. Here, for example, yeah, there's also, oh, I forgot to show you. There is, I'm going to go through it real quick. There's the voting token. See here, it inherits the ERC20 contract, all right? And it inherits the ownable contract. Ownable contract just makes it easier to use the only owner modifier and like make the function, make the contract just literally ownable. there's the constructor. This is how you call the constructor of the parent contract or the contract you're inheriting from. This is how you can override a function from this contract. And we have also a small mint function that only the owner can call. So the owner here can mint some tokens to the participants. All right, now here is the deployment. This is how you can deploy the contract. This is using the hard hat deploy library. It's a very cool library. That's my personal favorite library when like working with Solidity contracts, because it allows you to like save the deployments. So for example, here is the saved deployments. Here is the recorded transaction for the not recorded transaction. Like you can use this for verifying the contract. But yeah, a lot of cool stuff. Here it shows you, oh, here's actually the recorded transaction, yeah. And you can see the address, the API. Is just very cool stuff. Like you don't have to write this by yourself. It just does everything for you. You can deploy just this way by referencing the contract name. And yeah, that's it. You can explore the code a little bit more on our GitHub repository. I don't want to run late here, but I will just show the scripts that we wrote also. We can write scripts. So this script can add a new candidate, all right? We can see the owner here can execute the add candidate call, all right? See, from owner, log true, on the voting system contract to the candidate name. So here, execute, you don't have to like find the address of the contract and so on. Just the execute function from the hard hat deploy can search for the address of the voting system, all right, from here, find it from here, and then just call the function very easily. Like if you were to do it without this hard hat deploy, it will be much more complicated. But yeah, this is how we can call this script. Let's call it real quick. Hard hat run add candidate. All right, let's give it a new name. Let's give it like Ivan, maybe. All right, and let's do it. All right, now we have candidate Ivan with the ID. This ID is 3. All right, we can also vote for Ivan. Let's vote. So candidate ID 3. Vote.ts. All right, we voted for Ivan. Now Ivan will show us a little bit later how to see all of this. There's also real quick, I'm gonna show the tests. So do not forget to write tests for your contracts, all right? It's very important. I know everybody hates it. I used to hate it, but it is important to write tests. And here, yeah, we write them using Chai, and just hard hat makes everything easier for you. And you can use this template for almost all your projects that are related to Solidity. To deploy, just the last step. So we have one deploy script. This is called the deploy script. To deploy, you can say yarn hard hat deploy and specify the network, which is Metis. And now it will say that it's going to be reusing the old voting token. All right. Or deploy the new one. But no, we can use the old one, wherever it is. All right. This is how you deploy, and that's it. Sorry if I took too long, but you had to learn. How can we switch? Can someone switch to the slides from my screen? All right, great. So that's a live coding session for you. Now, I think Ivan can go now. I will hand it over the mic to Ivan. Thank you very much for joining. And yeah.
Yeah, thank you, Rami. So before I start, could you please tell me how much time do I have for my presentation?
I believe you have about 20 minutes.
20 minutes, right?
Yeah.
25. Okay. Thank you. So, hey guys, nice to present to all of you today. Thank you for joining us. So before I proceed with what Parsiq actually does and what we could accomplish with that, could you please write maybe a few words about yourself in the chat, like whether you are a developer or maybe a CTO or maybe an analyst, like what do you do, so that I will be able to specify my presentation and demonstration a bit more to the audience. Yeah, so Parsiq recently partnered with Metis, and we are pretty happy about that. And what Parsiq does is Parsiq brings blockchain data to the user, because as you might know, the blockchain data, it's basically public. It can be accessed through nodes and other things. But basically, to do so, you will need the infrastructure. You will need either your own node or an RPC node access or a data indexer such as Parsiq. So in case you don't want to host all this infrastructure on your own hardware, and in case you need fast and reliable data, you most probably, in search for blockchain data, will go for a data indexer such as Parsiq. So what does Parsiq do? Parsiq provides users who are basically developers or blockchain companies with blockchain data. It includes raw data such as transfers, native transfers, ERC20 and NFTs, transactions, including internal transactions like transactions between smart contracts and between EOA, external addresses as well. It provides information about the events with all the logs and function calls and all the other stuff. Yeah, so we have a question in the chat. Is Parsiq like Alchemy? I would say, yeah, like Alchemy is one of our competitors. And yeah, Alchemy is also a data index. It also provides an API to get the data. What Parsiq does, it brings you the data both historically, in case you need to look at the history of the blockchain of interest, such as Metis, for instance, or it also works in real time. So in case you need notifications or some data to be pushed, let's say, to your dashboard to notify your users, it's also possible, and Parsiq does it via webhooks. And also, Parsiq allows not only working with raw data, such as the data that can be found in the block, but also custom data logic. So let's say you need a balance of a certain wallet for a certain token. You can't find that information in the block or in the transaction. You can find only the information about how much was transferred. So in order to know the actual balance, you will need to go through the whole history of the blockchain, calculate how much was added and subtracted, and after that, you can get the actual balance. This is the simple example. More complicated examples are also available, such as TVLs for pools, or some APYs, or some other examples for your own smart contract and for your own logic, such as an example that we will take a look at today, which is the voting system that Rami just shared. So these are Parsiq technical capabilities, and let's also discuss what it can be used for from the use case standpoint. So a lot of our clients use us to power their graphic interfaces, dashboards with data. So let's say you are a wallet or you are some kind of DeFi protocol. So you want to be able to show your user how much funds they got, what transactions they've had, and so on. So this data can be acquired from Parsiq. Another example is getting data in bulk for analytics. For instance, if you want to look for some trading trends, or if you want to analyze the usage of your DeFi protocol, or and so on. And also, it can be used for machine learning. So you can download like a bunch of transactions as a CSV file and feed it to your machine learning scheme. Yeah, also, as I have mentioned, we have real-time data, so we can also power your application with notifications using Parsiq notifications about certain events or transactions bigger than a certain number or whatever. And also, you can use it as a B2D blockchain explorer. So the same way you're using blockchain explorers in browser to take a look at smart contracts and transactions and so on. The same way you can use Parsiq to explore blockchains from your scripts or from your code and power your code with that data. So yeah, that being said, I believe I can go straight to the technical demo. So please feel free to ask any type of questions in the chat. Also, feel free to request some particular use cases. So in case you're, for instance, interested in a specific DeFi pool on Metis chain, or you want to, let's say you have your own smart contract on Metis chain, and you want to monitor some events there, please feel free to share that in the chat. We will be happy to share that in our demo. If not, I have examples of my own, and let me proceed with that. Okay, so I will share my screen. Share screen. Entire screen. Share. Okay, and please, yeah. Thank you so much. So let us start with a simple example. So this is our API reference. I will give all the links to our docs, to our API reference, to everything in the final slide. So to get just the access to API, we need to go to docs Parsiq, and that's what we do here. So let's take a look at a simple example. So here I have the contract deployed by Rami. And let's take a look at some events here. For instance, we got this first event. So on this blockchain explorer, we don't have the decoded information, such as the names of functions. Still, we have what we need here, which is topic 0. So since we are about to monitor an event, we will need topic 0. But also, since we're going to monitor an event on a particular smart contract, we will need the address of this smart contract as well. So here I'm choosing the chain to work with. So our choice right now is Metis, mainnet, Andromeda. And let me enter the contract address here. And let me also specify topic 0. So to specify topic 0, let me show you this again. This works the same way on Etherscan and other chains. So let's go to, we see this. This is the page of the smart contract of interest. We see our transactions here. Let's pick this one. And if we go to logs, we will be able to see all the events happening during this transaction, and we will be able to see the topics, including topic 0, which is exactly what we're looking for. So let me put topic 0 here, and let me try it. Yeah, so what I did was I asked Parsiq for all the events with this topic 0 on this smart contract. And here is its response. So it gives us several events. And for each event, it has all the topics, like topic 0, topic 1. It doesn't, these events don't have topic 2, topic 3. It has the transaction hash, block number, timestamp, opcode, the origin of the transaction, and the contract which origin interacted. So yeah, that's how we get the data about events for Parsiq using Parsiq 𝘝𝘲𝘁𝗶𝘀 API. And let me show you other endpoints. So what data is available here? We have raw data on blocks, so we can specify, let's say we can get the latest block, for instance. or we can get a block using block hash. So let's get the latest block on Metis chain. For that, we need to just specify Metis chain. And yeah, in that case, we can get all the raw block data here. Other things that are possible with the Parsiq Tsunami API are transactions. We can see a transaction on a wallet. We can take a transaction by its hash. We can see transaction logs, for instance. Sorry, I misclicked. Yeah, transaction logs. So we can get pretty granular data here, and I don't think other solutions provide more granular data than Parsiq. Basically, Parsiq gives you everything that is on the blockchain. Okay, so also we have transfers, native currency transfers, ERC20 token transfers, NFT transfers. Also, we can monitor contract self-destructs and contract creates. Also, we can upload the API of the contract to get its data in the decoded format. And also, we can get the data in real time. For that purpose, we need to set up real-time filters, and we will get the notifications using webhooks. Yeah, also, we got such things as the NFT data lake and balances data lake. And here I will need to dive a bit into what the data lake is. So what I showed you before here, this is raw data accessible via the Tsunami API. And raw data is the data, as I have mentioned previously, in the form in which it is available in the block. So in the block, we have like function calls, events, transfers, and all the other stuff, but we don't have accumulated values such as balances, who holds which NFTs, who got how many votes, and so on. So in order to process accumulated data, we build data lakes. For now, we have two public data lakes, which are NFT data lake, giving information about NFTs like metadata, ownership data, transfers, holdings, and so on. And we got balances data lake, which gives the information about ERC20 tokens, like the balance of the set address or the holders of the set token. But the power of the data lakes is they can be custom, and basically I would say this is the deepest and the most important part of my today's presentation is our SDK and custom data lake. So obviously you can just call Tsunami API from your script. You can, for instance, if you're using Python, you can copy paste the resulting query right here, or you can choose any other language as well. But if you want to build a more complicated solution, like let's say in our example, we need to provide the user with the data on voting, and we will need to count these votes and return the number of votes for each candidate to the user in our interface. So for that purpose, we will try to build a data lake using our SDK. So as I have said, I will share the link to our SDK documentation in the last slide. So in case you want to try it yourself, you will be able to do so. But right now, just let me show you how the data lake works for this simple use case. So a data lake is basically a database. So in case you build a data lake using SDK, this database will be hosted on your machine. And right now I will show how it can be done. This database with the logic for the calculations based on the events emitted on the blockchain, it's running on your machine as an application, and it gets all the data from Parsiq Tsunami API. So it calls Tsunami API, gets all the data, and puts it in the database in the form that you specify. So let us talk a bit about what we have here. I believe Rami has already shown the logic of this contract. So we have candidates, we have votes, and we need to know how much votes each candidate has. We will be monitoring these two events, which is a vote event and new candidate event. They have candidate ID, a name, and number of votes, and they correspond to two functions. So in add candidate function, a new candidate event is emitted, and in vote function, vote event is emitted. So based on these events, we will monitor which candidate gets how many votes, what number of votes, and we will be accumulating it in our database. Let me show you the code. So you will get the structure of the project and the actual example code in the docs. So don't be scared. I didn't write all that from scratch because basically I'm not that much of a developer. I just copy pasted it and changed it according to the smart contract that I'm working with currently. Let's just go from top to bottom and you will understand what's happening here. So here we just include all the dependencies, make sure you install them correctly. Yeah, also let me share the documentation with you. I believe it should be somewhere here. Yeah, so and let me explain what's happening here. I believe I got like 5 more minutes, and I think it will be enough. So here I import the API of the contract under consideration. So in our case, it's a voting system, JSON. This API, I took it from here, from Rami's repository. You can see it here. And when it says API, from here and to the end of this bracket, you copy paste it, you create a separate file such as voting system JSON, and that way your data lake will know how to interact with your smart contract, what event it has, what event it has, what function it has, and so on. The next thing you'll need is 𝘝𝘲𝘁𝗶𝘀 API key, and I believe I just disclosed my own private 𝘝𝘲𝘁𝗶𝘀 API key, so I will definitely change it after this presentation. So how do you get it? You go to your Parsiq dashboard. It can be found here, and the link will be in the last slide. And in order to copy paste it, you just regenerate it, and you will be able to copy paste it here. So that's the next thing we need. Also, we specify the chain, so it might be Ethereum mainnet. In our case, it's Metis mainnet. After that, we specify the data on the contract, such as a contract address and the topics 0 of the events under consideration. And after that, we specify the block from which we want to track the events on this smart contract, because obviously, like if we deployed smart contract yesterday, we don't need to go through all the history of the blockchain. We just need to go from the block when it was deployed. The next thing is, I believe, is one of the most important things here, because it's the layout of our database. So we need to think hard on what we need to put here. Fortunately, our current example is pretty straightforward. So it's simple. It's the candidate ID, which is number, the name of the candidate, which is a string, and the number of votes, which is number again. Just ignore this one for now, because it's like for more complicated examples. After that, we specify the events, the types of events that we will be monitoring, like in terms of our TypeScript script, not in terms of Solidity, because we need to know what data we will be getting from them. And after that, we won't, I did not change this part. So basically, we don't need to discuss it for now. It's just copy pastable. And the next thing to change is to add our topic 0 here of our events. And as you can see, in this switch case, we call different functions for different events. So in case our topic 0 for our event matches the new candidate event, then we go to process new candidate event function, or we go to process vote event function. Yeah, and here, this is also more or less standard part, and you won't need to change. And an interesting part is here. So this is our key value storage. So this will be the key, and the key will be the candidate ID of the decoded event. Yeah, only as a string, because a key in this structure must be a string, not a number. And the value will be a structure of this type that will hold the number, which is candidate ID, the name of the candidate, and number of votes. So whenever there is a new candidate event, we create a new record in our database, which key is the candidate ID, and the value is all the information about the candidate with 0 count number of votes, because we just added this candidate. And then when we have a vote event, we describe this logic here. So what happens here is we take the current number of votes and we add the number of votes from the decoded event to the current number of votes, thus calculating the number of votes. I believe I'm running out of time here, but basically I have shown you all the code that I wanted to show, and now let's just make sure that this code works. So let me build it first. Cool. And now let me run Docker that will set up the databases and start scraping blockchain data. So it will start do the historical work starting from the block that I specified. And when it's done with historical data, it will be working in real time, getting the real time. So here you can see the number of block that it's currently working with. As you can see, it's the work in progress, so the number of block changes. Let me go to this database here. So here I have data grid connected to my database created by the data lake. And let's take a look at this table, candidate entities. As you can see, for now it's open. It's empty because the block, we haven't reached the block where the stuff happens yet. So let us wait for, I believe, maybe a minute, and it will go to the block that we need, and it will add the data and show us the count of the votes. Yeah, probably I will need to speed it up a bit. So let me do the following. Let me get the last block here. Yeah, so this will be the number of the block we're interested in. Let me put it here. Let's rebuild the project. And now let's run our data lake again. Yeah, cool. Now let's update it here, and we will see the events happened and being stored in our databases. Okay, yeah, probably we will need to wait a bit more because we haven't reached the block of interest yet. But I don't think we have the time for that now. Rami, do we have like a minute or two, or do we need to go?
Let me
You can
see.
extend it like a minute. It's okay.
Okay. So Kat said, yeah, we can have a couple more minutes. I hope that's enough.
Yep, it is. It is. I will just run our data lake again to make sure it shows us all the data that we need. So again, I will check the number of the block to make sure I didn't mess up here. So it was this one, right? Okay, and let me run the data lake again. Okay, now we can see that the data lake managed to get all the data correctly. So we have two candidates here. So as you can remember, Rami also added me, but we will see me later when the data lake scraps all the data from the latest block, because now we had just started with on the block where the first of the events were emitted. And you can see what we have here. So first of all, we have the changes that were made. You can see that there were added like Kevin and Rami. And also you can see the current values. So the number of votes for Rami is currently 0, and for Kevin it's currently for 500, I believe, according to the number of zeros. So so let me recap what we were doing here. We were monitoring the events on the smart contract, the new candidate events and the voting events. We added the new candidates to our database. And when we saw a voting event, we updated their number of votes according to this event. And that's basically a super simple example, but it shows us that using Parsiq SDK, you can build whatever blockchain data logic you need. You can set up thresholds, you can set up complicated logic, calculations, all inside of this data lake description, and it will provide you with the data that you need, be it the number of votes, or the APY, or the DVL, or some values that you want to calculate and show in your dashboard for your own application. At this point, I will stop sharing the screen, and I will ask the colleagues to show the last slide. I mean, the last of my slides.
All right. Oh, here.
Yeah. Great. Thank you, Rami. And so please find the docs. The first link is the one that will lead you to our API reference that I showed you. The second one is about Parsiq on Metis. The third one is the docs for our SDK. So using the third link, you could basically reproduce what I've shown you here with the voting system. And in case you guys have any interest in SDK, and in case you try it, or in case you have any questions about the API, please feel free to contact me in Telegram. So this is my Telegram handle. And basically, I will be super happy about any feedback on the SDK.
All right.
Yeah.
Thank you. Thank you very much, Ivan. Very awesome presentation. Really love Parsiq always.
Thank you,
so also,
it's been a pleasure.
Thank you. Also, don't forget to claim your attendance badge after 2 days. And the developers Telegram, you can join it. Ask any questions. I will be there. Just ping me, 𝗏𝘗𝘁𝗶𝘀. That's my handle. the GitHub template. Just take a real quick screenshot of this. It's a very valuable piece. It will be very useful for you. This is what I wrote for helping you to deploy a smart contract on Metis chain. And the Discord, you can join the Discord, but it's always better to be on Telegram. I will be 100% there. Thank you very much, everyone who watched, and thank you, Ivan, so much. Thank you, Parsiq, and sorry for our next hosts. Really wish you enjoyed our tutorial. Hi, Kat. Hey again. All right, kick us out.
All right, awesome. Thank you guys. I appreciate you guys walking everyone through how to build on. You guys have a great rest of the day. Thank you guys.
All right, thank you.